Good morning. Welcome to Digital Ship VPO webinar on case studies from vessel performance analysis. We are your hosts, Vaida and Carl, and here with us we have two guest speakers of XShip Design Analytics. Let me introduce you quickly to them. Sandith Thandasherry, he's the CEO. Also Syam Krishnan, Head of Performance Analysis. And very soon you will hear the case studies of work that they have done with their clients, monitoring more than 1,000 vessels and how it helps the decision making for ship owners. In fact, they also built a passenger ferry with no fuel on board, powered only with solar energy. XShip is also sponsoring this webinar, and we encourage you to ask many questions. And now I'm passing on to Carl to start the discussion. Let's go.
Okay, thank you, Vida. So what I think we're going to hear today is what happens when we look at vessel performance with the ship owner's decision-making put first. So what we often hear about is companies doing it in this order. They say we're going to gather data from the ship, we're going to analyze and collate the data, we're going to try and work out what the data is telling us, and then we're going to try and work out what decision we can make with this data. So I think XShip is doing it the other way around. They start saying, what exactly does a ship owner need to know? And like, do I need to clean the hull now, or where should I spend my money? And where am I going to make the most returns? And then how am I going to get the data to do that? So I think it's a far very ship owner orientated way to do it. So some of the case studies we're going to hear. So should we do a bow modification on a fleet based on the experience we did with one bow modification we made? What's the best frequency we should wash the propellers? Because we've got a propeller we coated with silicone. Does that mean we need to wash it more often or less often for the best performance? What's the impact of having a fouled hull on the amount of money we have to spend extra on fuel, which is a different, although related to the speed loss, but a different thing. And for a 23,000 deadweight ton chemical tanker, they had a look at the impact of a special polished coating and found that it was actually consuming 12% less fuel than in the sea trials because the paint gradually polishes and gets smoother. So this is very, very useful stuff for a shipping company to know. So XShip is in Cochin on the southwest coast of India, and they do monitoring services for 1,366 vessels with daily monitoring of 350 vessels. Clients are Mediterranean Shipping Company, MTM Ship Management, Pacific International Lines, Pacific Basin, Nippon Paint. You might have guessed that the core competency here is naval architecture. So Sandith Thandasherry, who's the CEO, worked as a naval architect before he founded the company. And you can hear a lot of naval architecture coming on in what you hear, but it's not just naval architecture. The company's also got mechanical engineers and mathematicians and other engineers in the staff. We're also going to hear from the head of performance analysis, Syam Krishnan, who's going to join us. Now, as a bonus extra, we're going to talk about the first time I've ever heard of this, putting solar panels on a merchant ship. So we've got a project where they evaluated putting a 200 square meter solar panel, which is there's enough space to put that on the above the bridge of the ship. It generated 25 kilowatts, and that's $90,000 cash flow over the lifetime. It doesn't need any batteries because the power is consumed immediately. Sandith has another sideline. He's a founder of a solar boats company called Navalt Solar and Electric Boats, which has built perhaps the first solar-powered ferry in the world. It's carrying 100 people, and it's carrying tourists in Kerala. So I'd like to invite Sandith to give his talk. Thank you. Cheers.
Okay. Thank you. So shall I just share my screen? Okay. So greeting to all viewers who are in different time zones. XShip is a software analytics company with core competence in naval architecture, data analysis, and software engineering. So XShip offers solution to the ship owners and managers in helping them save fuel and money directly by offering energy saving solutions, or indirectly by helping make decisions provided by insights, as well as save time by improving productivity. Now, XShip is one of the most experienced ship performance analytics company with over 1366 vessels as of today, and over nearly 5,000 ship years of extensive database. And this is a secret to our robust algorithm and high accuracy of our prediction model. Now, there are three types of savings which a ship owner can achieve. Now, first is clearly a direct fuel saving by an energy saving solution. Then the second is a savings obtained by enabling decision making. Now we can achieve it by evaluating savings from an energy saving solution, or the timing of maintenance, and by prediction accuracy. Now the third type is savings obtained by improving the productivity of superintendents and the support team. So there are many energy saving solutions available. XShip offers three of them: that is trim optimization, solar energy on ships, and large energy backup solution. The use of wind by suction sails and route optimization are under development. Now, trim optimization is the lowest hanging fruit among energy saving solutions. Now, we can implement in vessels by adjusting the operation and loading parameters. The ship has no extra installations and can achieve significant savings of almost 5%. The initial effort includes hull form modeling, using computational fluid dynamics to estimate the vessel performance at different speeds, draft, and trim. It is a qualitative assessment to obtain the trim table. The exercise objective is to understand the direction of performance, like going good or bad, when the trim changes from an even keel to either approach. It's not the exact value that matters, it is a direction that matters. Now let's look at a case study of a 40,000 deadweight handy-sized bulk carrier. Now we prepare the trim tables for the vessel after running the CFD, like what was shown in the previous slide. Then the client instructed the operation team to get the trim as close as possible to the optimum trim. And then we compared the voyages for the period before the optimum trim starting, as well as post that voyages. And the savings was about 5.9% in that 4-month period. Now for a vessel that requires about 19 tons per day for a 12 knot speed, these savings translate to about 323 tons of fuel, and at today's price nearly 130,000 US dollar. That's a significant savings for a ship owner. Now, installing a solar plant on a ship has two benefits. Firstly, it produces cheap power, and that means we can reduce OPEX. Secondly, we get the EEDI or EXI lowered. Now, we have identified 25 kilowatt solar plant as a scalable unit for commercial vessels where large installations are not possible because of interference with cargo operations like bulk carriers, tankers, containers. Ro-Ros are an exception where you can put much larger plants. Now this size of 25 is a sweet spot between the benefit of increasing size where you can achieve a lower per kilowatt cost versus the redundancy and ease of installation in steps when it's a smaller unit. Now let's look at a case study of an 86,000 deadweight bulk carrier. Now the solar plant here considered is a 25 kilowatt system, and it's installed on Monkey Island and accommodation deck. And this power is fed to the grid without batteries. Now the capex for this installation is about 20,000 US. Now the generator's cost of power, assuming a $450 per ton fuel cost and an SFOC of 225, is 11 cents per kilowatt hour. Now solar energy is free, but if you take the maintenance cost about 1%, that's mainly for cleaning and checking the panels, then the cost of power is less than 0.5 cents. Now for this investment, the break-even is 5 years. But it's not the break-even that is important, it's a life cycle. So if you see the entire life cycle and then also do a sensitivity analysis with respect to different fuel price, as you can see on the table on the left bottom. So we see that the break-even and the net cash flow is very high, including removing the cost of initial cost of investment. So that's a net cash flow. But in investments, it's very important to know the time value of money. So if you take a net present value, the assumption is about 5% as a cost of finance. We still see that even at low fuel price, the NPV is very high. So solar plant on ship is a great way to save money. Apart from that, from an EDI EXI point of view, a 25 kilowatt solar plant is equivalent to almost 5.6 kilowatt reduction in genset power for the purpose of this EDI calculation. Now, one lesson from the previous case study of solar plant on ship is that batteries make sense if the solar energy cannot be consumed and it needs to be stored. It is not the case in most commercial ships. Hence, there is no need to add batteries to store solar energy. However, there is a different reason to have large battery banks. One of them is to shave that peak power on a genset. This power spike is mostly in reefer containers as an example. Then the route optimization is another great way to save fuel by choosing the path using future weather models with lowest fuel consumption and low cost. But both are different, like especially when ICA zones comes into play, the lowest fuel consumption may not be the lowest fuel cost. Now again, our module route optimization is under development. However, our simulations show great potential for saving. And when it comes to renewable energy, wind is much more impactful in the sense of scale of energy production. Wind is much more powerful than solar on a typical commercial ship. There are many ways to get this wind energy. We are working on suction sails. What is common is this rotary cylinders like Maersk and all does that. Understand? We work on slightly different stuff. It is a cylindrical stationary sails, but it's slightly elliptical section with a suction pump at the trailing edge to prevent the separation. We've done this land-based testing and hope to do a ship installation by end of this year. Now, the second type of savings obtained is by enabling decision making. Now, there are three groups in this. The first is by evaluating the savings from an energy saving solution. Now, this helps the ship owner whether to replicate the same across the fleet or discontinue the idea. Now, the second is enabling the timing of maintenance. Now, this includes both maintenance trigger to save money as well as to evaluate saving. The third group is prediction accuracy. It helps to get contracts, prevent penalty, and also to do vessel ranking with similar vessels in the platform or under consideration. Now, ISO 1930 has brought in an industry standard for estimating the variance in performance. Now, speed loss is a metric used. There are some limitations in ISO as far as ship owner is concerned, because ship owner finally needs to convert this variation to gain in fuel and money or loss. Now, we do this by adding a proprietary algorithm on top of this ISO 1930, where we can provide the percentage in fuel gain for any intervention, including an energy saving solution. Now, these reports help ship owner take decisions on projects where investments could be considerable. Now, let's take a case study of a 23,000 deadweight chemical tanker. For one vessel in the series, the client applied the low friction paint during her new build time. Now, we had analyzed this chemical tanker during her voyages, and the ship was consuming less fuel than her sea trials. Now, after a year of assessment, we confirmed that there was a 12% reduction in comparison. That's mainly because of the polishing effect of the paint, which was mentioned earlier. The total degradation in the year was also very low, which is about 0.5%. These are usually the paint guarantees. Now, the savings of these was estimated at $170,000 US in 1 year. And this case enabled our client to apply low friction paint on their next takeovers and for their existing vessels in their dry dock period. Now, similarly, there are various other cases. One where it was successful in the sense that a large container fleet could monitor the significant reduction in propeller degradation using silicone paint, and they made it as a policy decision across the fleet to make the same. Now, there is also cases where we didn't get the benefits. Like, for example, this was a bow modification done on a container vessels. Once the speed changed from 24 knots to 18 knots as a low speed reduction, what they tried, the fuel saving achieved did not achieve or justify the considerable investment made in this project. Hence, the client decided not to continue with bow modification in other sister vessels and other ships in the series. Now, the flip side to this support, what we provide is to what we give to the energy saving solution companies like Nippon Paint Marine. Now, Nippon use our system to convince ship owner using our analysis results to showcase the benefit of their high quality paint. Now, the degradation assessment also helps their internal R&D to improve their product performance. Like Nippon, we partner with hull cleaning providers and other solution providers to highlight the benefit of using their solution. Now about timing, like earlier our clients used to schedule their hull and propeller cleaning at regular intervals. Now we help them monitor this degradation and time of maintenance so that they can save fuel. Now we set these expected degradation based on the paint applied, sailing routes, and trigger an early intervention if the actual degradation is more than expected. Now, the interaction of a ship with external factors yielding required consumption is a very complex process. Now, variation in speed, cargo weight, and weather, along with the hull, propeller, engine condition changing, makes it very difficult. Hence, the prediction accuracy becomes essential. Now, for any given speed, cargo weight, and weather, the estimation of fuel consumption is this challenge. If we overestimate the consumption, then getting contracts, especially when you are chartering out, getting contracts will be onerous. If you underestimate it, then the risk of penalty is high. Now, another need for ship owner is to rank the particular vessel along with a similar average ship. It helps in many of this decision-making process. So the next is productivity perspective. So savings obtained by increasing the productivity of people. Now we can achieve in 3 different ways. Like first is by quick access to ship's data and reports, like the smart data module helps in achieving this. So this is a case where we can see how quickly one can access a ship drawing. Right? So this same can be used for certificates, manuals, reports, and other forms of data. Like a lot of alerts for certificates, surveys can also be set in this platform. So the next group are supporting the report generation and statutory compliance. There are a whole lot of items here. Many modules are there. Some of them are listed below. Just as an example of a cold landing app for a vessel, especially visiting the California ports. Now this app helps the user comply with this 3-hour rule there. So this is just how report is there is a checklist and the report is generated and submitted to the management team. Now a related capability where we support the ship owner is helping in the design process based on our robust naval architecture and engineering team in XShips. There are a lot of things we do for the ship owner. Now we try to capture the entire breadth of solutions that that helps the ship owner achieve savings. So for more information, you can ask questions now or reach us to the email mentioned. Thank you.
Well, thank you very much. So I'd like to invite the audience, if you have questions you'd like to ask, there's a Q&A button at the bottom of the screen. There's a couple of questions we got already. Just a sort of warm-up question from me. So as a journalist, I often get all these press releases from companies talking about machine learning and AI all the time. And it's very, very fashionable in sort of maybe Europe and the West. But I think your perspective, you obviously haven't gone down that road and you can see what ship owners want to hear. But do you find this frustrating that people often ask you, they want to hear about machine learning and how many data scientists do you have, rather than wanting to know what domain expertise you have? Is that it?
Yeah. No, there is a overemphasis on talking on big data, machine learning, and AI. In our limited experience of these 1,000 ships, what we see is purely if you go by data analytics, without putting the underlying physics in mind, we try to get the accuracy in prediction rather than the reality. So, which is our experience is to go with an underlying physics and try to build on the models to improve the accuracy and tweak the algorithm. This is the direction we are going. Parallelly, we are testing whether the AI models are becoming stronger day by day. So we do that as well, but we still feel the other approach is still more accurate than the pure data play and AI play.
Well, what do you think is most convincing to a ship owner? I guess when they can see the graphs like the one you just showed, this is what you thought you'd save, this is what you're actually saving. I guess that gets the message across very well to somebody rather than saying I have 100 data scientists in my office.
Yeah, absolutely. At the end of the day, finally, they have to see the numbers, like whether they are really saving fuel and whether they are really saving money. So if you can get that, so that is why we always think from the ship owner side first, rather than telling what is our computer's RAM or what is our AI and capability. We see what they need finally is to assess this measurement of saving and help them in decision making. So this is finally what they want, and we work backward to see how that can be achieved by using a lot of tools available and build and optimize our solution. That's the direction we take. So yeah.
Well, and on the solar power, I mean, I was just thinking, you've got 5 kilowatts for a solar power, but the vessel propulsion could be sort of 50 megawatts or something like that, can't it? So it's still a very tiny amount. But I suppose that you might be a generator that's much smaller than that, but it's quite a small generation in proportion to the overall power of a ship. So I'm wondering how much time it's worth a shipping company putting into when it's such a.
So one thing, I mean, since we are building solar boards itself, which consume zero fuel, the mission is always to reduce fuel. It is not always to make it zero. For some applications, you cannot get to zero immediately. So we almost always have to do is how to reduce. And the reduction process has to be economically viable. So the point is, if you want to save $10,000 in fuel, you just cannot spend $200,000, right? So you need to spend less than $10,000 and achieve the saving. So solar panels are clearly that. So you spend 20,000, you get 100,000 in the lifetime, right? And with today's present value, it's about 40,000. So that is the way you have to approach. It's not always that you get suddenly you spend $1 million and you get $1 million. There are not many solutions like that. So you do that incremental step, improve your savings, save money. Both has to go hand in hand. This is at least what I believe. So there is no point in offering solution which doesn't make money for the client. So only give solution which saves money, and you can establish that it saves money. Solar is by far much easier to show the savings because it's pure electric power you're generating. You can monitor it without any doubt in terms of how is my performance. If it's in hull paint, etc., you can always argue, is it because of the weather? Is it because I am in a different route? There can be questions, but solar, there is nothing to question because it's pure electrical power measurement. And then how much you are offsetting from the genset is very easy to measure, very easy to establish. So it's a clear play, although it's not significant from a percentage of the energy consumed by the ship, but every small drop matters. So in that sense, it matters.
Oh, sounds great. Well, if we go to the Q&A box, should we invite Syam to open his camera and his microphone now? I don't know who's the best. The two questions right at the top here. So Peter and Franz both asking about noon reports. I think it's a lot of challenges. We often hear about this challenge of collecting data. So you're getting the data from noon reports. Are you validating the data? Do you have an app for a noon report? Do you want to maybe take those two together?
Yeah. Syam, you want to tell that?
Yeah. So the data, we have the tools to collect data from the from ships. We have offline tools. It works as online, both online and offline, which helps them to validate their data inputs against what they're reporting is correct, to check that. And after validating, we are taking in for the analysis. There is a training session for the say first 3 to 6 months to get them familiarized with the tool and to get them enter right values. So we validate and give the feedback. We generate alerts, like the daily alerts for the both to the ship manager at the shore and to the vessel on live.
Oh, so the seafarers are entering the data at noon every day, or do you have any live data from the ships as well? Or?
Yeah, we have live data collection. We have from our 350 ships, almost 200 ships are giving us data every 5 minutes, which we are collecting it live. Others are following noon data. So we have experience with both the noon data system and the automated frequent. Even some vessels we are getting at 10 seconds data every 10 seconds.
Okay, and Franz is also asking, does your app comply with the regulations for replacing paper reports?
Yeah, regarding the known reports, we have there are several compliances to be taken with the flag stakes. Example, Singapore flag, if the vessel is having, it has to be complied with the MPA rules. So that will be complied, and wherever the flag approvals are there, we currently have the Singapore approvals. So we take it that way, get the approvals for it.
Okay, so the next question, I don't actually understand this myself, hopefully you will. The roller drafts in trim optimization from Captain Marwa.
Yeah.
I thought trim optimization was all about drafts.
That's true. So maybe probably what he meant was at whether the optimized trim changes with the draft as well. That is correct. So for each combination of draft, speed, the optimum trim keeps changing. The table is different. So the key is to get the qualitative, sorry for that. The key is to get the qualitatively where the direction of optimum trim is at any drafts, and then observe in reality. This is where many times the solution providers do not focus too much. The key is not necessarily to get the accurate value by CFD. CFD only gives an indicator. Then you have to establish in real data, and we play with real data. Hence, we give a lot of emphasis on the real data, and the original trim table is just a reference point from where you build your the real optimum trim.
Wow, so the optimum trim is different if you're in deep water as in shallow water. Crikey, that's complicated.
There is also that effect too. Yes.
Oh.
So that usually the dynamic draft indirectly takes care of it, but yes, the reality is what finally matters.
Okay, so next, so we're going back to this data gathering. This often comes up in our webinars. Thing people want to ask us a question about. So Anton is asking, if you can't get high frequency data, what do you do? But because some speakers say they don't want high frequency data. Lots of people we've had saying the noonday report is ideal rather than getting data all the time, you know.
So in our experience, a lot of insights can be gained by noon data itself. It is only the confidence improves with high frequency data for sure. And the time for arriving at a decision will also increase if it's purely known data. But the indicators can be obtained with either of them. It is probably the accuracy and how quickly you can determine will slightly change, because we have a healthy mix, and for all the vessels we have high frequency data. We also compare with the known data and then assess how robust the algorithms are, and then thereby we are making this comment.
Oh, okay. So Siddharth, if I pronounce that right, is asking about the weight increase of your solar panels.
Oh yeah, that's very insignificant weight of a solar panel. So say for example, per kilowatt, it is about 50 kilo. So it's a very, very small weight for the ship. So yeah, it wouldn't matter. So there is very little modification you have to do on the systems. And it's also a small power, and the power can easily interact with the nature of power produced by the genset. So you just can feed into the grid. It automatically adjusts to the grid characteristics, and you can feed it. It's also very small power. So it wouldn't even matter from an overall perspective. So aim is to at least reduce 1%, 2% there overall.
Okay, so Nikos, we're back to data gathering. So is it your company that does the data gathering, or do you leave it to the shipping company to provide the data and set up the infrastructure to do it, or somebody else?
So we can, in some of our clients, they already had the system in place, which is the hardware and the mechanism to get the data to shore. But there are some clients who do not have, and then they are looking at ways how to do it. So we facilitate that as well. But from an analytics perspective, we are hardware agnostic. So we do not impose our hardware on any client. If they need support, we can do with our partners and our team to install these equipments with whatever choices they want to take with some guidelines. So it's practically we are hardware agnostic. That is key here. And yeah, so that's the mix here.
Oh, so Nitin is asking about the difference between trim optimization and hull optimization. I guess hull optimization is about fouling, is it? And trim is about how it sits in the vessel on the water.
Yeah, so hull optimization. So there are, so from a trim optimization, when we use an hull optimization, it's usually in the design perspective. Usually that's what first time it came to my mind. So optimum hull, which is the point here is when we are trying to design a hull, we try to optimize a hull from a performance at the some trim, but at a particular draft to meet the dead weight, like the shipyards will do that way. So it's not necessarily focusing on trying to get the optimum trim also in the process, because they have to establish sea trials in only one condition. They don't have to do in many conditions. So they will only choose the one condition where it is most suitable for their performance side. But trim can be in multiple combinations. So it's not necessarily the same, but the same approach. It's a CFD approach to get the thing from a theoretical perspective, but finally validated in reality. Both hull and trim, both finally has to be validated in reality. Hull you do in sea trials as well, but trim you do in actual running conditions.
Oh, okay. So Kumar Sundaram is a friend of ours. He's the senior IT project manager with Anglo Eastern. So he's asking what specific high frequency data do you collect from ships? So for Syam,
yeah, there are two ways we can get the automated data. One is, as Sandith has mentioned, the ship owner already has some sort of system to collect the automated data. In that case, we are very flexible to get the data in a specified format, which is given by the hardware supplier. So the second case where there is no data collection system available, so we have partnered with a certain hardware team to supply this data collection system to the ships, so that the data is collected with our own hardware and it comes to our server directly. So in both cases, it is not affecting the quality of the data. Only if we have the high frequency data, then we have almost a lot of bunch of data to do the filtering, validation as per ISO standards or statistical methods. We have certain tools here to validate the data. So in both the cases, the analysis results will be fine with automated data. And currently we have from 10 seconds to 5 minutes, every 5 minutes we are receiving data from ships.
Oh, so Nitin is asking about your suction sails.
Yeah.
Do you want to talk a little bit more about that and compare with wind sails?
So, suction sails and old wind sails both work on exactly the same principle. You have, just like plain wings, it's the same principle. You create a lift by having the camber or the shape. But what is difference between an old sail and suction sail is that you are increasing the camber, or you are making it more and more closer to a circular. The issue in reducing this is that you will have a separation of the flow, which is why old sails are having a very nice shape. But it increases the footprint. But in commercial ships, we need a low footprint. So we need to increase the camber to make it close to circle. That is one. So there's a slight difference there. But to prevent the separation of the flow, you have a suction pump on the trailing edge so that you don't have a separation. So you are introducing some electrical power to prevent the separation by suction pump, but you are reducing your overall footprint for a commercial ship, and then generating the thrust, which is what finally helps move in, whether it's in the old suction old sails or the suction sail, will give you the thrust to move the ship, and that is how you save fuel by. adding to the propulsion energy or the thrust to reduce your engine consumption.
So what is it actually sucking? So you have a pump sucking air into the sails?
So yeah, so if you have a flow around the suction sail and it is going on the trailing edge, because of the steep change in shape, the flow of the wind can have a tendency to separate out from the surface of the sail. So that preventing the separation is done by some suction pump along the line of the trailing edge from top to bottom of the cylinder, so that you don't have a separation and it smoothly follows the shape of the sail, suction sail. So that's the idea of a pump.
Oh, that's very good. So next we're going back to the high frequency data collection. I think I learned something about this looking at this coronavirus numbers, because I learned it's much more useful sometimes seeing numbers per week than it is seeing numbers per day in terms of understanding what's going on. But yeah, did you?
Yeah,
I don't think you.
Syam already mentioned
Yeah,
that.
and one more thing I can add is if we are following ISO 19030 standards in that strict sense, it is suggested to have data collection every 10 seconds. We are taking 10 minutes band of data to apply proper validations and filters. So ISO suggests a 10-second data, but in practical sense, we are doing with more frequent data, less frequent data also, say 5 minutes or 10 minutes also we are doing. But ideally, it should be 10 seconds.
And what data is it? Is this the fuel flow, or what data are you collecting every 10 minutes?
The data is it's from the power meter, the power, the speed of the vessel, then the factors affecting the power or fuel consumption, like the environmental factors or the draft or the speed of the vessel or the direction which the vessel is, the course of direction, all this wind, yeah, and the environmental parameters, of course. All these parameters which is affecting the fuel consumption we collect.
Okay, so the next two questions are about solar panels. Vivek is asking if they're corrosion resistant, and Neelab is asking if you actually tried them out. I know you tried them out on your own ferry. But...
Yeah, correct. So those two answers I will combine.
Oh, and the next one, Vivek, is also the life cycle of the panels.
Okay, so all three I will answer. So basically, we have done on all our sea vessels, boats which are both seagoing as well as inland, and for commercial ships also similarly, which we are doing. So the key here is there is a difference between panels which are kept on the land and one we put on the sea or on the ships or boats, right? So they have certain additional IEC standards to meet this salt water resistance, etc. So that is essential. So it's not the same panel. So they need to meet certain standards. And then these panels have guaranteed performance life of 25 years. And here guaranteed is from your original rating power, you will reach 80% after 25 years. So it's not that it is useless after 25 years. It reaches 80% of its original. So that's a very guaranteed return. It's a very proven technology. So no item you will get guarantee for 25 years with this kind. So that's exactly why solar is so easy to do and makes more economic sense. Yeah. Yeah, and the space it's mentioned, like, so each panel, or let's say for a 400 watt panel is 2 meters square. So that's the kind of space. So it's about 5 meters square per kilowatt. So yeah, so it's a very small area. So you to get a 25 kilowatt is easily achievable in most commercial ships. It's the steps of 25 we are looking at, 25, 50, 75. In different locations for easy installation and scalability.
Well, what are the risks? I suppose nobody's going to be walking on them if they're on the top of the Monkey Island, but they could have saltwater corrosion and could be a lot of moving about.
Yeah, so of course you leave space for walkway and maintenance. I mean, maintenance means you may want to wipe after a month or 2 months or once in few months. That's only maintenance per se. And if you are using the right panels, then they will not corrode because it is aluminum frame and glass. So there is nothing to corrode per se. The only thing is bimetallic because you are in contact with steel. You still need some solution for it, which we do in our boat. So for the steel structure. So that's also there a solution.
Well, and have you tested them on any deep sea ships? I mean, I guess the ferries is a good
So
test.
all the sailboats, even sailboats, they are deep sea. I mean, practically, right? So sailboats have these solar panels. So it's not something new technology. It is already there. Commercial ships, I think NYK, one large installation is there on NYK Ro-Ro vessel. And similarly, we are trying to do for MSE, these Ro-Ro vessels. So, and that has been there for some almost 7 years now.
Oh, okay. The next question I don't understand. Maybe does down by head in general? Do you know what that means? Is that a term?
Yeah,
You
it's
reckon?
a trim optimization question.
Oh, right. Okay. Well.
So, so it is not not general. We have seen in many cases where, see, we anticipate that typically ships are either slightly down by stern or even keel, but some or many cases it's either even keel or slightly down by head. But we don't want to generalize. It's a very depends on the shipyard standard series. So we have certain group of such standard series where we have the data, but I don't want to generalize across board. Yeah.
Okay, I think you're a real expert in all this stuff. I think there's a lot of questions coming up. So Omar's now asking you about your about the paint. How much does the thickness and chemical composition of the paint affect performance of the ship? How do you study it using CFD? I guess obviously.
Yeah, so it's obvious that the chemical composition of the paint affects the performance. When paint companies actually are putting forward many theories, many composition that they claim they give benefits. The recent one we have studied is that low friction paint, which smoothens on its use. So it will be consuming less than the sea trials or less than the beginning times. Ongoing, it will get smooth. So that the kind of a compositions are there. Paint companies are researching and putting forward many solutions for this. Obviously, this will affect the ship performance. And this a paint effect cannot be studied by using CFD because this is the actual savings we measure. We are not changing the hull, but changing the application of paint on the hull. So what is the actual data consumption after and before this painting has to be compared to get us what is the exact benefit, operational benefit of applying this paint.
I just want to add on that CFD part. So CFD is a good technique, but still approximate. So it cannot be used for this nuanced decisions where we are talking a 1%, 2%, but it can give the direction. So to give the direction, so it's a qualitative decision and not quantitative. So do not depend on CFD for these quantitative decisions. So you don't go with that 1%, 0.5% and depend on CFD, never. So you depend only on the real data. The issue in that is you will finally have to spend the money to on this high quality paint at least once to establish that. That's the only flip side. But CFD has a lot of limitations. So you should understand that when we are trying to use it for these kind of applications.
Okay, so Peter Brand is asking, how are you calculating speed? Are you doing speed over ground or speed through water? And if it's and where'd you get these figures from?
Yeah, speed over water is a good parameter to measure, is what we think. And the parameters we measure, the sources will be different because high frequent data, say every 10 seconds, there should be sensor from the vessel which give us the data. Otherwise, more frequent data, we may have to depend third-party suppliers of weather supply. We have tied up with weather suppliers also to get live updates of weather every 1 hour. So for less frequent data, like data is collecting every 1 hour without any sensors, we have tied up with the AAS data and the weather data to get these things accurately. For more frequent data, obviously there's the sensor data which is directly coming from the sensors from the ship.
Oh, okay. Should we go to Paul Kursgaard Nielsen? So how do you validate the noon data report when there's often problems with crew members don't typing data consistently or
we have a set of validations, around 30 to 40 validations we have on live when we get the noon data in. So that is a primary validation that is done automatically, and feedback is sent to the ships and their shore managers. And during our analysis, we study different relationships between different parameters and what is the expected versus what is reported by them. This is a detailed analysis where we help them to point out where can be the improvements happen. So we have seen in our experience, we have seen the first part, the direct data monitoring, the automated one, that improves a lot in first 3 to 4 months. That is like a training session. That is our experience. So after the 3 to 4 months, we can have a detailed analysis on the data coming in. So we have a quality data in hand.
Oh, okay. So we've got two questions on solar panels.
Yeah.
I think Anil hasn't. This point about you're not using the deck space, and are they waterproof?
Yeah. So for these bulk carriers, tankers, etc., what we discussed is all putting on the accommodation area, Monkey Island, above the accommodation decks, and not touching the cargo space. Though technically you can do on bulk carrier hatch cover as well. That's a technical point you can do, but it's not. We are talking still on the accommodation area only, where there is no interference with cargo operation, and trying to do in steps of this 25 kilowatt to achieve the savings for that investment and returns on that particular investment. And these solar panels are waterproof, no issue. There is no protection. As long as you don't jump on it, it is okay. Nothing will happen. There are specific panels which have very rugged panels are also there, which may be twice as expensive, where you can run vehicles on top also. So there are panels for that purpose also. If you have to put it on a walkway, that is also there. Yeah.
Oh, so Henrik is asking about ISO 19847. I haven't come across this before, but just it's a standard for shipboard data services to share field data. Is that something you get involved with?
If that is a requirement, obviously we will do that. But normally for the analysis, we have our own validation methods and data collection tools and the validation methods, so we don't depend on that. But if that is a something like it's a mandatory, that also we are doing.
Okay, so two questions from Kumar about coating. So do you like silicone-based paints, and is the coating on the bottom or just on the sides?
There are different scenarios on that. We have done the case studies with only the vertical sides or the bottom is only painted, and painted without a proper blasting, just the short blasting and painting after that. That is a case-to-case analysis, which will be benefit for you, and what is the benefit you are gaining with what only vertical sides doing. That's a case-to-case doing. So the answer will be ship specific. So what I suggest is we can do that case study with the data from the vessels directly.
And also the silicon for propeller, if it is the surface preparation is done correctly, it definitely gives benefit. That was seen across a large number of vessels.
Oh, okay. So Eirik is asking about these robotic hull cleaning solutions. I think Jotun has another one. I think that the web address is shipsave.no without the 3 W's when I tried it, but I don't know if any of your clients have asked about this. So when you have a robot on the hull that does it automatically, but the important thing is the decision about when to clean the hull, I suppose, rather than the technology itself, maybe, isn't it?
Correct. That's right. So what was this question on the robotics?
Well, I think it's a sort of promotional question. Have you come across his product? I think, but I mean, just talking about robotics in general. Is that something you?
Okay. Yeah. So technically, as you rightly pointed out, the timing is what matters, and the kind of cleaning to establish. Like, for example, there are some cleaning service providers who claim that the kind of cleaning or the brushes they use do not damage the paint, compared to certain which does damage, which show immediate benefit but significant degradation after a month or two. So the exercise is to identify if the type of cleaning is also good or bad is also done there. So it's not just necessarily in that 1 month, 2 months after that, but in a 3 months, 6 months period, whether it really gave the benefit, that particular type of cleaning. This also we have done as a case studies.
Wow. Okay. So this last question, quite hard to answer this one. The accuracy of your models, is that something you're able to answer? Do you think?
Yeah, so we had indicated in one of the slides on the accuracy, and the way we measure accuracy is what we predict and what we are seeing in reality. That's the only way we know how accurate is a model is. And in high frequency data, we are getting close to this 95%, 92 to 95%. And on noon data, again, that depending on the other parameters like quality of reporting, wind, etc. This noon report can have a range between 85 to 92%. This is what we have seen from a prediction versus observation. So yeah.
Oh, okay. Well, maybe a last question for me. I'm fascinated by how you thought when you were planning this company, because I saw on your LinkedIn page you ran a naval architecture company, but then you launched this. So it's naval architecture driven, but with a lot of analytics. And you obviously want to get a balance between naval architecture and the analytics, which makes you very special, because none of the other companies in this space are doing that I've seen. They're mainly all analytics. I don't know if you want to say.
So again, I look from one step broader. Our objective is how we can save fuel and energy. And we are trying to say broadly how and all we can do. So from a boat perspective, the objective is to reduce fuel consumption by better design and using solar and other solutions for boats, right? So that's one way to save fuel. And in the large ships, the other extreme is you do by these energy saving solutions, or you do by these analytics, and all these are spread. Fine objective is to save fuel, save money. So it all connects there, saving energy, saving fuel. So that's a common link, and various streams we may encounter a domain where we have no domain expertise. So we get that expertise on board to ultimately meet the objective of saving energy, saving fuel, saving money. So that's the three companies which we are working on. Yeah.
Oh, sounds great. Do you want to have a go at these last two questions from Nitin? So I think model testing, I mean, your models are based on actual data. They're not based on probabilities. So I guess you...
Yeah, correct. So
I don't understand. How do you convert the ratio of fuel savings? I don't know
what does
ratio
that
he means.
mean? Can Nitin elaborate the question if he's live now?
Yeah. But the models should be based on actual data, aren't they? They're saying this is what the data shows us. And
yes.
There we go.
From speed loss to okay. Yeah, okay. So yeah, Syam, you want to tell a bit more?
Yeah. Normally, yes, your question, I think it arises from the scenario that ISO 19030 is giving speed loss, or telling how to calculate speed loss, and not telling something about fuel savings. So normally normally anybody assume is that fuel and speed is a proportion, like a cubic relation exists in between. So it's what is the speed savings in speed, or the speed loss multiplied by 3, you will get a fuel loss. That is a theory what everybody is doing, most of the people are doing. But from our experience, what we see is that many sea trials, when we check, the relation is not like fuel is proportional to V cube. It can range from 2.5 to even 4, depends on the size of the vessel, type of the vessel, etc. So without knowing that exact coefficient what the ship holds, we cannot convert that speed loss to fuel savings. And so that better way will be not by simply multiplying with a coefficient, but to directly measure the fuel and normalize it, say normalizing it for a constant draft and a constant speed. Then we compare the normalized fuel consumption before and after the event. We directly get the fuel savings. So that is a real fuel saving we are getting, instead of going theoretical by multiplying with a coefficient on it.
And we have had multiple instances where we had to fight with paint companies on behalf of ship owners to convince this point. Instead of just simplistic models, go to the real models and show the real benefit of their paint rather than just multiply by 3 as an arbitrary number. So So we have had many such interactions where we were on the ship owner side to convince the paint guys.
Oh,
So and even your vessel is vessel's speed fuel relation is not in cube, and less than 3 is the factor for your vessel. Maybe the energy saving solution suppliers will be extrapolating their savings by multiplying with 3. Actually, you don't have that much savings. Or otherwise, in case you have a coefficient more than 3, we are underestimating the savings. Both the cases we have seen.
Yes.
oh, that's fantastic. Well, you've answered about 30 questions now. That's phenomenal. I think maybe we'll close the Q&A now. I don't know, Sandith, if you'd like to take a couple of minutes to say a wrap up, or what you'd like to, customers welcome to see your website and contact you there if they want.
Yeah, so I can just put that. Sorry, okay, yeah. So as we have seen from our various case studies, we have a breadth of experience in different energy saving solutions to the way the ship owners can save money by decisions and productivity. So if you have any questions, you can always reach out to us. We can help you assess the savings. Even if you are coming directly with saying that you have come from the seminar, we will also give you a free pilot.
Oh, very good. Okay, well, I'll pass back to Vida for the closing words. Thank you.
Thank you, Carl. And also Sandith and Syam from XShip for sharing practical example what's possible to do with performance analytics to improve decision making if you are a performance monitoring department, operations, or even commercial team member. Next Thursday, we are discussing a bit unusual topic for us, reducing delays in port calls. There is still time to register, and now Digital Ship is signing off. Take care. Bye.
Oh, bye-bye. Oh.